Alright, Honors Chem, I'm going to finish up the answers videos with one final problem, 7-6. You can skip 7-3 and 7-7. I'm just going to eliminate those from the problem set. Okay, so 7-6 will be the last problem. Okay, so let's go ahead with this. So, assume you dissolve 2.56 grams of malic acid, there's the formula, in 500 grams of water. Calculate, and it gives you 4 things to calculate. So, molarity is going to be, and oftentimes when I have these kinds of compounds like this, I just abbreviate it CHO. It's the CHO compound, okay? And rather than writing all the little numbers, that's not really necessary. Okay, there I've written all the formulas for molarity, for molality, for mole fraction, and for mass percent D. All right. So one thing we're going to need pretty much in somewhere along the way in these problems is you're going to have to know grams of each and moles of each. So let's go ahead and calculate the moles of malic acid and the moles of water. We're going to need that for the mole fraction down here. So let's go ahead and do that. So first we need the molar mass of this. It's going to be okay, we add those up. Okay, and for water, and hopefully everybody knows this one by now. Don't even have to do the numbers on it. 2 hydrogens and 1 oxygen. Okay, so now we have the grams of the molar mass of each. The molar mass of this one is, again, I'm going to go back to just CHO as a shorthand. Okay, so now we're going to compute that for each. So we have 2.56 grams of malic acid and 500 grams of water. So now we can compute moles of those two, and we'll know everything, the grams of both of those and the moles of both of those. Okay, so this is how many moles of malic acid we have. That's 2.56 grams in water, 500 grams, and we get 27.7. Okay, so there's moles of water that we were given and moles of malic acid that we were given. So now we can come back up and work through these. Okay, so moles of CHO over liters of solution. Well, here's a problem. We don't know how many liters of the solution we have. We can assume that the liters of solution is very close to the liters of water. You can't always do that. But if you do it, you should state that as an assumption, that you're adding so little of this malic acid that you really haven't increased the volume from what it was when it was just water. Is that accurate to do that? Technically, no, but state it as an assumption, and you can maybe get away with it. Okay, it depends. It has to be a very small amount of malic acid that you added. So we're going to write this as an assumption here. For this one. Okay, so where did we get the 500 milliliters? The 500 milliliters is, we have a conversion that 1 gram of H2O, this is only true for water, equals 1 milliliter of H2O. Okay, that's only true for water. All right, so if we have that conversion, then we can go ahead and put this, then that means that 500 grams of water would be 500 milliliters. So we're going to go ahead and just use that assumption. It's not absolutely accurate, but it's the best we can do. Otherwise, we couldn't solve the problem. All right? So you can either state the problem can't be solved, or you can state, if you make this assumption, you can go ahead and do it. And I'd rather you do that, make that assumption. Okay, so here we go. So it's moles of CHO. So we figured that out down here. It's 0.019 moles of CHO. 191. Okay, what we're trying to get to is moles of CHO over liters of solution. Okay, so we have moles of CHO on the top. We need to convert milliliters to liters, so that's just one simple conversion. Okay, milliliters solution cancels and cancels, so you have liters of solution on the bottom, moles of CHO on the top. So we're going to just do a multiplication, so 0.019 times 1,000 divided by 500, and that gives us this. There it is, and that's of course molarity. That's what this represents, so you would write it this way. Okay, so that had to assume that we had 500 grams of water, which equals 500 milliliters of water, and that even when we added the malic acid, it increased that volume so little that we could treat that as liters of 500 milliliters of solution, even though technically that's not correct. Okay, and generally in problems you don't do that, but that was just one case where you could. Okay, let's keep going. So now we have molality. Here it is. So again, it's moles of CHO. Okay, and it's over kilograms. So what we can actually use the actual amount. It's over kilograms of solvent, and that's the water. So we can actually go ahead and put in our 500 grams of H2O that we know we actually have. We don't have to make any approximation or assumption here. So what we're shooting for is, for molality, is moles over kilograms of water. Well, moles is already correct on top. Grams on the bottom, we need to get it to kilograms, so it's just simply a standard conversion for anything. Now we have kilograms on the bottom, so it's 0.19 times 1,000 divided by 500, and we get the same thing. Okay, since we were treating solution and solvent as the same here, effectively, then you ended up with the same answer there. Okay, but it is technically a different calculation. And this one was an approximation. This one is exact. You can write that. This is exact. And of course, this is molality, so you write it as this. Small m. And this was large M for molarity. All right. Let's come down here. Now it's simply going to be mole fraction. So we have the moles down here, 0.019 for CHO and 27.75 for the water. You don't even need to write the units because everything's going to be in moles and they're all going to cancel. So moles of CHO, down here same thing, plus moles of water, and you add that up, and what we get is this. And there's no units because all the moles here canceled out. It's just a fraction. It's called a mole fraction, but it's really expressed as a decimal. And so there it is right there. This is such a small fraction. That means the malic acid is such a small fraction of the total mass in grams, and therefore also the total volume, that it's okay to make this assumption up here that we did, that the volume of the water and the volume of the solution, that is when the malic acid is mixed in, are pretty much the same. So that kind of justifies that assumption. Okay, and one more. Grams, so times 100%, so that's going to be 2.56 grams of the malic acid. And it's done just like mole fraction, except with grams. It's the mass of the entire solution. Oops, made an error there, sorry. That's the mole number for water, but the grams is what we're interested in here. So that's, going back up here, that's 500 grams. Okay, and for this we get 0.51%. So basically 0.5% of the solution is the malic acid. That means if you take 100% minus 0.51, that'll be the percent that's the water. Okay, but you didn't ask you that, so you don't need to do that. So there's the answer for that. Okay, so that takes care of this problem, and just ask you to kind of wrap up by doing a problem where you had to figure out pretty much everything. Okay, that's it for this assignment. This is going to be due on Wednesday for period 1 and on Thursday for period 3. Okay. And that's it. So we'll see you in class.